TW conductors are not rated for direct burial. According to the National Electrical Code, the following types of conductors are permitted for direct burial. Firstly, type UF or underground feeder. Secondly, type use or underground service entrance. Thirdly, type RHW or resistant heat and moisture. Fourthly, type RHW-2 or resistant heat and moisture, rated for 90 degrees Celsius. Fifthly, type RHH or resistant heat and high humidity. Sixthly, type RHH-2 or resistant heat and high humidity, rated for 90 degrees Celsius. Seventhly, type XHHW or cross-linked high heat and moisture resistant thermoplastic. And eighthly, type XHHW-2 or cross-linked high heat and moisture resistant thermoplastic, rated for 90 degrees Celsius. Therefore, it is not legal to directly bury TW conductors. The situation of having number 2 aluminum TW black conductors leaving a disconnect in conduit underground, and they are not in conduit at some point, presents a safety hazard. TW conductors are not rated for exposure to moisture or sunlight, and they can deteriorate over time, potentially causing an electrical fault or fire. An action plan should include, firstly, excavating the area where the TW conductors are not in conduit. Secondly, inspecting the conductors for damage. Thirdly, replacing the damaged conductors with conductors rated for direct burial, such as UF or RHH. Fourthly, ensuring that the conductors are properly protected from moisture and sunlight. And fifthly, reburying the conductors at a minimum depth of 18 inches. When dealing with electrical installations, strict adherence to the National Electrical Code is crucial. The NEC provides guidelines for safe and effective wiring practices, and it is essential to understand and follow these regulations to prevent hazards and ensure the longevity of electrical systems. The NEC specifies the types of conductors that are suitable for direct burial based on their insulation properties and resistance to environmental factors. Conductors approved for direct burial have robust insulation that can withstand moisture, soil chemicals, and physical stress. Type UF, or underground feeder cable, is a common choice for direct burial applications. It is designed with a thermoplastic insulation that is resistant to moisture, chemicals, and abrasion. UF cable is suitable for both residential and commercial installations where underground wiring is required. Type use, or underground service entrance cable, is specifically designed for bringing power from the utility service to a building. It has a durable insulation that can withstand direct contact with the earth and is also resistant to sunlight and weather exposure. RHW, RHW-2, RHH, and RHH-2 conductors are also approved for direct burial. These conductors have thermoset insulation that provides excellent resistance to heat, moisture, and chemicals. The numeral 2 suffix indicates that the conductor is rated for a high temperature, allowing for increased ampacity in certain applications. Type XHHW and XHHW-2 conductors are another option for direct burial. These conductors have a cross-linked polyethylene insulation that offers superior resistance to heat, moisture, and abrasion. They are commonly used in both residential and commercial installations for a variety of underground wiring needs. When installing direct burial conductors, it is essential to follow the NEC guidelines for burial depth. The minimum burial depth depends on the voltage of the circuit and the location of the insulation. For example, for residential branch circuits rated at 120 volts or 240 volts, the minimum burial depth is typically 12 inches. For higher voltage circuits, the minimum burial depth may be 18 inches or more. Proper burial depth protects the conductors from physical damage caused by digging, landscaping, or other activities. In addition to burial depth, it is important to consider the type of soil and the presence of any underground obstacles. Rocky soil can damage the insulation of direct burial conductors, so it is advisable to provide a layer of sand or other protective material around the conductors. Underground obstacles such as pipes or other utilities should be avoided or carefully crossed to prevent damage to the conductors. When splicing direct burial conductors, it is essential to use connectors and methods that are specifically approved for underground use. These connectors are designed to provide a watertight seal and prevent corrosion. Heat shrink tubing or epoxy-filled splice kits are commonly used to protect underground splices from moisture and chemicals. Before backfilling the trench, It is a good practice to inspect the conductors and splices to ensure that they are properly installed and protected. Any damaged conductors or faulty splices should be repaired or replaced before the trench is closed. Backfilling should be done carefully to avoid damaging the conductors. Using a layer of sand or other fine material around the conductors can provide additional protection. Once the trench is backfilled, it is important to clearly mark the location of the underground wiring. This can be done by placing marker tape or signs above the conductors to alert anyone digging in the area. Marking the location of underground wiring can help prevent accidental damage and ensure the safety of workers and homeowners. When dealing with existing underground wiring, it is essential to exercise caution and follow safe work practices. Before digging in any area where underground wiring may be present, it is important to contact the local utility companies to locate and mark any underground utilities. This is a free service that can help prevent damage to underground wiring and ensure the safety of workers. If you encounter any underground wiring during excavation, it is important to stop digging immediately and contact a qualified electrician. Never attempt to repair or move underground wiring yourself, as this can be extremely dangerous. A qualified electrician has the training and equipment to safely handle underground wiring and can ensure that the repairs are done properly. In summary, TW conductors are not approved for direct burial, and using them in this way creates a safety hazard. When installing underground wiring, it is essential to use conductors that are specifically designed for direct burial, such as use RHW, RHH, or XHHW. Following the NEC guidelines for burial depth, splicing, and protection is crucial for ensuring the safety and longevity of underground electrical systems. The information provided is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before undertaking any electrical work. Always prioritize safety and follow all applicable codes and regulations. Remember that electrical work can be dangerous, and it is essential to take the necessary precautions to protect yourself and others. By following these guidelines and working with a qualified electrician, you can ensure that your electrical systems are safe, reliable, and compliant with the National Electrical Code. Additional considerations for ensuring the safety and compliance of underground electrical installations include proper grounding, bonding, and overcurrent protection. Grounding and bonding help to protect against electrical shock by providing a low impedance path for fault currents to return to the source. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overheating and causing a fire. The NEC provides specific requirements for grounding, bonding, and overcurrent protection of underground electrical systems. It is essential to follow these requirements to ensure the safety and reliability of the installation. Proper documentation and labeling are also important aspects of underground electrical installations. All underground wiring should be clearly documented on site plans or as-built drawings. The location of splices, terminations, and other components should be accurately recorded. Labeling of underground wiring is also essential for identifying the purpose and voltage of the circuits. Proper documentation and labeling can help to prevent confusion and errors during future maintenance or repairs. Regular inspection and maintenance of underground electrical systems are also important for ensuring their continued safety and reliability. Underground wiring should be inspected periodically for signs of damage or deterioration. Splices and terminations should be checked for corrosion or loose connections. Overcurrent protection devices should be tested to ensure that they are functioning properly. Any problems that are identified during inspection should be promptly repaired to prevent further damage or hazards. When making repairs to underground electrical systems, it is essential to use the correct materials and methods. Replacement conductors should be of the same type and size as the original conductors. Splices and terminations should be made using connectors and methods that are approved for underground use. All repairs should be thoroughly tested to ensure that they are safe and reliable. In addition to the technical aspects of underground electrical installations, it is also important to consider the environmental impact. Underground wiring can have an impact on soil and water quality, so it is important to take steps to minimize these impacts. Using environmentally friendly materials and methods can help to reduce the environmental footprint of underground electrical installations. Proper disposal of waste materials is also essential for protecting the environment. By considering the environmental impact of underground electrical installations, we can help to ensure that these systems are sustainable and environmentally responsible. The information provided here is intended to provide a general overview of the requirements for direct burial of electrical conductors. It is important to consult the National Electrical Code and local electrical codes for specific requirements in your area. A qualified electrician can provide expert guidance on the design, installation, and maintenance of underground electrical systems. Remember that electrical work can be dangerous, and it is essential to take the necessary precautions to protect yourself and others. Always follow safe work practices and use the correct tools and equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. By following these guidelines, you can help to ensure that your underground electrical systems are safe, reliable, and compliant with all applicable codes and regulations. In addition to the above information, it is important to note that some local jurisdictions may have additional requirements for underground electrical installations. It is always a good idea to check with your local building department or electrical inspector to ensure that you are in compliance with all applicable codes and regulations. Also, remember that the information provided here is not intended to be a substitute for professional electrical advice. If you have any questions or concerns about your electrical system, it is always best to consult with a qualified electrician. A qualified electrician can assess your specific situation and provide you with the best advice and solutions for your needs. They can also perform any necessary repairs or installations to ensure that your electrical system is safe and reliable.